centimeter long at a certain temperature. What is the length for the temperature rise of 100 Kelvin if the linear expansivity of the brass is 18 times 10 raised to the power minus 6 per Kelvin? Solution. Let L2 be the length at 100 Kelvin. Original length of rod L equals to L1 is equals to 2 meters. Rise in temperature of the rod is equals to 100 Kelvin. From linear expansivity, alpha is equals to L2 minus L1 all over L1 times temperature rise. Expansivity is 18 times 10 raised to the power minus 6, which is equals to L2 minus L1 all over 2, the original length times 100. Cross multiplying, we have 18 times 10 raised to the power minus 6 times 2 times 100 is equals to L2 minus 2. Making L2 the subject of the formula, we have 18 times 10 raised to the power minus 6 times 2 times 100 plus 2, which gives us 2.002036 meters. Question 14. A piece of copper of mass 50 grams at temperature of 250 degrees Celsius is placed in a calorimeter of mass 70 grams containing 60 grams of water at temperature of 20 degrees Celsius. Ignoring heat losses, what will be the final steady temperature of the mixture? Specific heat capacity of copper is equal to 400 joule per kilogram per Kelvin. Specific heat capacity of water is equal to 442,000 joule per kilogram per Kelvin. Let T2 be the final temperature. Heat lost by copper is equal to heat gained by copper plus that of water. So we now have mass times specific heat capacity S over in bracket TCU minus T2 is equal to MC of the calorimeter, specific heat capacity of calorimeter X in bracket T2 minus TC of calorimeter plus mass of water times specific heat capacity of water in bracket T2 minus TW. Substituting the values, we have 0.05 times 400 in bracket 250 minus T2 is equals to 0.07 times 400 in bracket T2 minus 20 plus 0.06 times 4,200 in bracket T2 minus 20. By multiplying the terms, we have 20 in bracket 250 minus T2 is equal to 28 in bracket T2 minus 20 plus 252 in bracket T2 minus 20. Opening the bracket, we have 1250 minus 5 T2 is equals to 7 T2 minus 140 plus 63 T2 minus 1260. Collecting like terms together, we have 1250 plus 140 plus 1260 is equals to 72 plus 63 T3 plus 555 T2. Therefore, T2, making T2 the subject of the formula, we have T 2650 over 75, which give us that 5.3 degrees Celsius. Question 15. A piece of copper of mass 300 grams at a temperature of 960 degrees Celsius is quickly transferred to a vessel of negligible thermal capacity containing 250 grams of water at 25 degrees Celsius. If the final steady temperature of the mixture is 100 degrees centigrade, Calculate the mass of the water that will flow with boil away. Specific heat capacity of water is equal to 4.2 times 10 raised to power 3 joule per kilogram per Kelvin. Specific latent heat of vaporization of steam is equal to 2.26 times 10 raised to power 6 joule per kilogram per Kelvin. Solution. Heat lost by copper is equal to heat gained by water. 0.3 times 400 in bracket 950 minus 100 is equals to 0.25 times 4200 in bracket 100 minus 25 plus 2.26 times 10 raised to power 6 times mass. 0.3 times 400 times 850 is equals to 0.25 times 4200 times 75 plus 2.26 times 10 raised to power 6 Making m the subject of the formula, we have 102,000 minus 78,750 all over 2.26 times 10 raised to power 6, which is equals to 23,250 over 2.26 times 10 raised to power 6. Therefore, m mass is equals to 0.0102876 kilogram, or mass is equals to 10.3 gram. Therefore, mass of water that will boil away is equals to 10.3 gram. All the heat generated by a current 2 amp passing through a 6 ohms resistor for 25 seconds is used to evaporate 5 grams of a liquid at its boiling point. What is the specific latent heat of the liquid? Solution. Since energy is conserved in the process, heat generated by electricity equals heat gained by the liquid. Electric energy supplied is I squared RT, which is equals to ml. Therefore, 2 squared times 6 times 25 is equals to 5 mass times L, making the L the latent heat of vaporization, the subject of the formula. We have 4 times 6 times 25 over 5, which gives us 120 joule per gram. Specific latent heat of the liquid is equal to 120 joule per kilogram. Now we are into waves. Waves, content wave. 3.1 is wave. 3.2 is light wave. 3.3 is electromagnetic wave. 3.4 is application of light wave, sound wave, and application of sound wave. Waves. Wave motion is the process of transferring kinetic energy from one point to another without any transfer of matter between the 2 points. Example are mechanical waves, example sound and water, and electromagnetic waves, example light and radio waves. Waves. Wavelength. Wavelength lambda is the distance between two successive crests AA. The SI unit is meters. Amplitude. Amplitude A of a wave is the maximum displacement of particles from their equilibrium position. From the graph of distance displacement time, the amplitude is A, while the wavelength is lambda.